All right. So we are looking at equations versus inequalities. So these are ones where oftentimes they're almost so easy they're difficult because there are very similar features between them that get people kind of mixed up between, wait, this one, and they're so close but so different, and it gets a lot of people. But we want to look at the concept of how to be able to go out about solving inequalities versus equations. And so the important thing to note is that you're going to solve them basically the exact same way. So where equations represent the equal sign and only a certain number, like x equals 3, and inequalities has multiple options, at least 4 sets. You have the classic greater than or equal to, less than has the small point or equal to. That's what this other half of the equal sign is. So they take that one or equal and just put it with it. We have greater than, again, reading on the left-hand side, you have the larger end of the arrow here, oftentimes referred to as the alligator. And then you have less than, which is the small point of this arrow. And that actually equals a span of numbers. So where this represents just one number typically, down here it says there's a large variety, or at least a larger variety of numbers that will still fit their criteria and make something true. Okay? So let's look at what it means to solve these. Okay, so you solve an inequality using the exact same methods or way as you would with solving an equation, except one thing. If you have to divide or multiply by a negative number, then you have to flip the sign. Okay, so let's look at this in action. We have our 2 examples, and what you see is just that. We have our typical equation. We're multiplying both sides by 2, but it's a positive 2. We subtract 4 from both sides. But down here, we have to divide by negative 3. And in the other situation, it just stays x equals. No big deal. But with the inequality, we do the exact same steps as we do with the equation. But when we get down to having to divide by a negative number to both sides, we have to flip our sign, because it's saying the opposite of that is this number here. So it means the opposite of greater than is also going to be applied. Right? So if we're doing the opposite of the sign, we have to do the opposite of this sign as well, the inequality sign, in order to keep the statement true. So graphically, these are some things to kind of keep in mind when it comes to graphing, and obviously I use the number 3 in the situation here. Graphically doing an inequality compared to an equation is usually, if you said x equaled 3, then you have a solid dot. Boom. No questions, no ifs, no ands, just x equals 3. Not 4, not 5, not 2, not 0, 3. But if it's an inequality, then you start getting a lot more variance and flux. Like, well, actually, x could be greater than, again, it's on the larger end of this arrow here, greater than or equal to 3. So that means it could be 3. That's a solid dot. or it could be greater than 4, 5, 6, 7, and those are all okay numbers. As long as it's not 2, or even 2.5, or 0. Those won't work at all. And what we have is what's called a closed and the open. Just a quick refresher on these here is that if you have a closed dot, then you have a closed symbol, which is usually represented by the bracket here. If it's open, which means that it either continues on forever in terms of infinity, or is literally like the open dot that you have here. Okay? So x is less than, it's on the little tiny end here, so it's less than or equal to 3. Then again, that means it could be equal solid line. I like to say solid line, solid dot. If not, then not. Okay? So if you have a solid line, you have a solid dot. If there's not a solid line, then it's not a solid dot. Okay? So, or less than, or you could do just x is less than 3. That means it could be 2.5, 2.9, but it just can't be 3 itself. As soon as you become 3, you are no longer part of the solution in this situation, or the possible answers. And the same thing is if x is greater than 3. So again, since it is greater than, it has an open parentheses, and it continues on infinitely. Okay. So this is the starting point, this is the ending point, this is the starting point, and this is the ending point. So this is another way to be able to indicate these numerical graphs. Alright, so this is a brief introduction in terms of how similar, if you notice they all land on 3, but what they do with that 3 and whether 3 is included or not, and whether options above or below 3 are acceptable or not. All are close but yet different than the normal equations. And the same thing up here. Very, very similar, almost identical, until you multiply or divide by negative. Alright.